Good morning, Year 10, and welcome to a new week and a new topic. First, I would like you to complete the low stakes quiz, so pause the video here and answer these 8 questions. Okay, so going through those questions, identify the charge of a proton, neutron, and electron. They are +1, 0, and -1. The function of a chloroplast is photosynthesis. The function of the mitochondria is respiration. The definition of the independent variable is change. So that is the factor that you change within an experiment. The definition of a control variable is that it must stay the same. And the dependent variable is what you are measuring. A couple of questions here that are going to take you back to where you did electricity at Key Stage 3. So I'm hoping you can remember current is measured in amps and potential difference is measured in volts. And of course, we're going to cover a lot more on that in the next couple of weeks. So our learning objectives for today's lesson are that we need to be able to identify circuit symbols. Many of these you will already know, but there will definitely be some new ones. Recall and use the equation Q equals I times T, and I'll come on to that later. And explain the concept that current, which you should have heard of before, is the rate of the flow of charge. And again, I will go through that in a lot more detail further on through the lesson. A couple of key words for you. And again, I will give the definitions of these as they come up in the lesson. Current, charge, potential difference, and resistance. And some of these come up today, some of these are coming up tomorrow. Okay, so first of all, I want you to draw and label the symbols in pencil. Anything that's got a yellow box or is highlighted in yellow, you must write down in your notes. So if you want to pause the video here and write that out, it's a sheet of A4 paper that I've used and I've just made a grid. I'm going to talk through it in just a minute and make some additions to it. I don't mind whether you draw it as I go or once you've drawn it, then watch the additions that I'm adding to it. Okay, so there we go. So you need to be aware of the fact that the cell is what pushes charge around the circuit. The battery is 2 or more cells together. And you will have seen these in school before. So when you use these back in year 8 and you made little circuits, that is what you're using. We call these cells. Okay, and this is where we've simply got a battery together. Okay, an open switch. Well, current cannot flow. And so whatever components are in that circuit won't work. And there is an expectation that you are aware of. For an electric circuit to work, it needs to be complete. Okay, and this is what I'll be using in our experiments as a push switch. When I push the button down, I push the switch in and the circuit works. When I let it go, it's released. So it's a slightly different symbol, but the symbol of an open switch and a closed switch where current can flow, completing our circuit. Filament lamp, a circle with a cross in it. Now a filament lamp or bulb works by current heating up the filament. and that means it emits light. The ammeter measures current in the units of amps, or amperes, but amps for short. The voltmeter measures potential difference. And this is measured in volts. Resistor is a resistor. Here's my resistor. Okay, so this is what the symbol of a resistor looks like, which is actually very close to a picture of what it looks like as a component. And what this does is it resists. So it slows down or stops that's what resists means, current flowing around the circuit. Okay, the variable resistor does exactly the same thing, but here you can vary the amount of resistance, whereas in my resistor, this one, the resistance is fixed. Let's write that down. Whereas in the variable resistor, I can change the amount of resistance. So it's everything from this box plus changeable level of resistance. Okay, a fuse. And what we have in a fuse is we have a very, very thin wire. Now, you can't quite, oh, I think you can just see the wire in there glinting. But what is in this little glass cylinder is a very, very fine piece of wire. And what this means is that if too much current flows around the circuit, so something has gone wrong and there is too much current flowing, the fuse will break. And that's why it's very important to have the right size fuse for your circuit fitted. Okay, a thermistor. So this is what a thermistor looks like, and this is a temperature sensitive resistor. And a thermistor has a high resistance at a low temperature. So the colder it is, the more resistance this has. The warmer it is, the less resistance will be in this circuit. Okay, a diode and a light emitting diode. So these two, look how similar their symbols are. They're both very, very similar components. However, the light emitting one obviously emits light. However, the key bit with a diode is it only allows current to flow in one direction. And a light emitting diode, when that current is flowing, light is emitted. Okay, we're getting there now. So on to the light dependent resistor. And very similar in relation to the thermistor, the temperature dependent resistor effectively. At a high light level, this will have a low resistance. And conversely, at a low light level, it will have a high resistance. Okay, last one is a heater, and this represents a component where heat is emitted. Okay, so I will upload this picture that I've been writing on, and if you've got a printer, you're welcome to print it off, but you do need to have that in your notes, and you need to be aware of that so you can come back to that. Okay, so what I want you to do now is to, in your head, or draw out these lines. I do not need you to spend time writing the words down. So if I was doing this, I would be working out which way they go. I don't expect to see any evidence of this in your notes. This is for you to check that you actually know what they are. So put away what you've just drawn and see if you can connect. And what I'd hope is that you would be able to imagine in your head that the ammeter is going to the ammeter, the battery to the battery, the cell to the cell, diode, fuse, lamp, light dependent resistor, light emitting diode, resistor, open switch, close switch. Variable resistor, there. Need to do that. Voltmeter, and thermistor, I couldn't see it there. Okay, so I'm not expecting to see you having done that, but I do want you to check that you can. And there's the answers a little bit more clearly than my scribbles. Okay, now these I do want to see. I don't want you to write the question. I want you to write your answer in a sentence. So I'm expecting 8 sentences. I'm not expecting this to take you any more than about 8 minutes. And in theory, it should be quicker. 8 minutes is the absolute longest you should be spending on this section. Pause the video. The answers will follow. Okay, use green pen to correct your answers to those questions. Remember, they are a required part of this lesson. Okay, so we are now on to explaining the concept that current is the rate of the flow of charge. Now, before we can explain that concept, we need to remind ourselves what charge is. Now, from the chemistry lessons we've done, we are well aware that electrons have a negative charge. However, they are tiny. Remember that you get approximately 2,000 electrons in the mass of a single proton. We cannot measure their charge in individual electrons. So what we talk about, is we talk about charge in terms of coulombs. Now, a coulomb is simply a big number of electrons. You need to write this down in yellow. So charge is the flow of a large number of electrons. 1 coulomb is 6.25 times 10 to the 18 electrons flowing. So lots and lots and lots, far more than we can realistically understand and think about. The next section that we need to understand is current, and we need to know that current is the rate of flow of electric charge per second. So current is how much charge we had on the previous page that is flowing around a circuit per second. This is carried by electrons in the wire. So think back to the chemistry unit on bonding. Remember our metallic bonding where we had the positive metal ions with the free flowing electrons. It is those electrons that are moving within the wire that are moving the charge around the circuit. When we talk about current in an equation, we use the symbol I, and it is measured in amps, and we use A to represent that. We now come on to the equation that we need to learn from this lesson. And the most simple format of that is Q equals IT. Now we're using Q to represent electric charge, where we have the units of coulombs. So this is what we've got here. Electric charge measured in coulombs equals current measured in amps times time measured in seconds. Now I haven't gone through time in seconds because I'm going on the basis that you understand that already. So in order to work out these questions, we need to use this equation exactly. We need to make sure everything is in the right units, so amps for current and seconds for time. That will give us our answer of electric charge coming out in coulombs. So when we do a question like this, we write our equation down. Q equals I times T, and that equals 2.5 times 100, which is of course 250 coulombs. That is our answer. That is as simple as it needs to be. I want you to pause the video and do these 5 questions exactly like that. Okay, so going through the answers to those now. So question 1, we should have had 0.2 times by 45, which is 9 coulombs. I've done that without a calculator, so let's just double check. Yep, good. My mental arithmetic is still good. Question 2, we've got 3.1 amps, so we should have had 3.1 times 104. And we should have come out with an answer of 322.4 coulombs. The circuit has a current of 400 amps and it's on for 0.3 of a second. So we've got 400 amps times 0.3 of a second, and so we've got 120 coulombs. Finally, we've got, 5 amps times 180 seconds, which is 900 coulombs. And we've got 8.9 amps times 78 seconds, which is 694.2 coulombs. Okay, so hopefully you're feeling confident at using the equation this way round. Now we need to go on and look at what happens when we are given the electric charge and we need to calculate either current or time. So here we've got a question where we are being asked when a circuit is switched on for 200 seconds, so we're being given a time, 1,000 coulombs of charge flows. So we now need to rearrange this equation in order to work out what the current is. So we want to move T to the other side of the equation because we want to make current the subject of our formula. And so what we need to do here, in order to make current the subject on this formula, we need to divide this side by T. And if we're dividing this side by T, we must also divide this side by T. That means then this cancels out, and so I equals Q divided by T. And you need to be confident on rearranging those equations. So I equals Q divided by T, so we've got 1,000 divided by 200, equals 5 amps. Make sure you're sure of how to do that because you're about to go on and practice that. So pause the video here and do these 5 questions. I equals Q divided by T. So going through the answers then, we've got 45 divided by 38, which equals 1.8 amps. Here we've got 5690 divided by 1010, and that equals 5.6 amps. Here we've got 46 divided by 18, 2.5 amps. Here we've got 490 divided by 2 minutes, so we must convert that to 120 seconds. And there, that is 4 amps. Find the current at 520 divided by 52 equals 10 amps. And again, I hope you're finding that relatively simple. The difficult bit is rearranging the equation. Once you've got your equation rearranged, then it's a case of plugging the numbers into it, making sure, like in the case of number 4, that your numbers are in the correct units. Okay, so final one, we now need to rearrange the equation the other way round. How long does it take for a charge of 520 coulombs of charge to be transferred in a circuit of 4 amps? So this time, we're now looking to make T the subject of our equation. Now, in order to remove the I on this side, we're going to need to divide by I, which means we must therefore divide this side by I. I cancels out on the right, so our equation for this is Q divided by I equals T. So 520 coulombs divided by 4 equals 130 seconds. Go on and attempt these 5 questions of deliberate practice. Pause the video now. Okay, welcome back. So before I start, I'm just going to write down on this side over here, so Q divided by I equals T. So I haven't got very much room on these first 2 to write, never mind. So 12 divided by 4 equals 3 seconds, and 800 divided by 2.5 equals 320 seconds. Now we've got 48 coulombs divided by 0.4. Remember, I'm dividing by a decimal, so I'm expecting my answer to be bigger. Is 120 seconds. Current through a bulb is 85 coulombs divided by 1.7 is 50 seconds. And finally, 150 coulombs divided by 12.5 amps equals 12 seconds. Okay, so hopefully you are feeling confident on using that equation in all three variations of it. It is simply a case of rearranging that equation. And that is something you've done in maths, but I'm also teaching you each lesson in science on each equation, exactly what we're doing and why we're doing it. So, uploading your work, I'm expecting to see the notes from the lesson, so anything I've either highlighted or outlined in yellow. I'm expecting to see the deliberate practice questions on the function of the circuit components, not cell components, sorry, typo there. And I'm expecting to see 3 lots of 5 questions from the charge calculation questions uploaded. Make sure that's on there by 9 p.m. tonight, and I'll be having a look through tomorrow. Thank you very much, Year 10. Have a lovely rest of your day. Goodbye.